RIP stands for Routing Information Protocol, and it's one of the oldest dynamic routing protocols around. Now, just because it's old, don't think people don't use it. It's still used quite a bit, but usually only in small networks, ones that don't change very often. So, let's get a few basics down. Number one, RIP is an interior gateway protocol, okay? So you're not going to be using it to connect autonomous systems. And secondly, it's a distance vector protocol. Now, what I want to talk about is the first version of RIP, or RIP 1. Okay, so to explain RIP, I've got 3 routers, X, Y, and Z, and I've got 3 networks, A, B, and C. And what we're going to do is we have just made these 3 connections between these 3 routers, and we're going to watch what happens with RIP. So, as these routers connect, now keep in mind, in order for RIP to work, all of these routers have to be configured for RIP, and they have to be RIP capable, and they are. So, the first thing that's going to happen, this router already has a route to network C, this router already has a route to network A, and this router already has a route to network B. So it's routing tables, each one of these has one route built into it. They don't know about each other yet. Now, they're connected, so they know they can start talking, and over a given fixed interval, they'll begin to speak. And they will start showing each other their routing tables. So what's going to happen on the first swipe, and let's concentrate right over here with router Z. So router Z knows how to get to network C, so he's going to go ahead and send that to these 2 routers. In turn, these routers are going to send their connections to the other guys. So in the first click of the clock, this router right here, he knows how to get to network C through himself, he knows how to get to network A through router X, and he knows how to get to network B through router Y. So he has 3 routes built into him in that first sequence. Now, over the same fixed amount of time, these routers will talk again. Now, think about this for a minute. Here's router X. He knows how to get to network B through router Y, correct? Z knows how to get to network B through router Y, but using this connection. So on the next time they compare notes, suddenly router Z has 2 different ways to get to network B. He can do it through X, or he can do it through Y. And that's why RIP uses the hop count as part of the metric. So with RIP, he's going to take a look and he'll go, yes, I can get to network B through router X, but it's going to take me 1, 2 hops to get to it. I can get to network B through router Y with only 1 hop. So this guy right here, now that he has 2 different ways to get to network B, he's going to simply delete the one with the longer hop count. So that works out pretty well, and that's the basics of how RIP works. The downside to RIP is that it takes a while to get convergence because it has a fixed time interval between the individual times that they start comparing each other's routing tables. The other issue that comes into play is that RIP version 1 had some real limitations. For example, RIP version 1 could only deal with Class A, Class B, or Class C networks. So if we used CIDR rules, for example, if we had a WAC 28 network, it just didn't work with RIP version 1. So RIP version 2 came along, and RIP version 2 took care of 2 big problems. Number one, it can handle CIDR-based networks, so it'll deal with WAC 28, WAC 29 networks. And secondly, it has security built into it, so it's not that easy for bad guys to come in and mess that stuff up. So that's RIP in a nutshell. And remember, it's easy to find RIP, and Network Plus is going to ask you some good questions on it. Make sure you understand the big issues. Oh, one other big thing. RIP had a maximum hop count of 15 hops. So you couldn't have a network bigger than 15 hops between 2 network IDs, or it simply didn't work.